Okay, so Yaniva's going to tell. We had his should I say boss or partner? Boss.
Sure, boss.
For the main monthly meeting a little while ago, Professor Peter Blamey, got that right?
Correct. Yeah.
And he sort of explained to us more the sort of overarching considerations of the hearing aid and reasons why it's better than the traditional kind of hearing aids that I haven't got on today. But Yaniva's going to get a little bit more. That's why.
I'm saying that's why, because we think our hearing aids sound better. I mean, obviously we're very biased, but that's what happens when hearing aids don't sound good. People stop wearing them.
Yep. Well, yes. And I go into a restaurant and they amplify the ambient noise. Mm-hmm. Actually, on my trip, we got chatting to a lady who has a speech. She teaches lip reading. And she sort of gave me one little tip. She said, when you're in a restaurant, sit up against the wall. At least then you don't have any noise coming from behind you. And that's actually a good little tip. Mm-hmm. Next time I'm in a restaurant, I'll try doing that when we go out with friends. Yeah, so sorry, I'm wandering a little bit. So from Yaniv, we're going to get a little bit more of the intimate internal details of how his hearing aids work. So over to you, mate.
Okay, thank you. So when I spoke to David and through the emails, I was trying to gauge what to talk about, really. And I don't think I got a great picture because it's difficult, right? It depends on what each person in the room is more interested in, right? So I've got these sort of slides and I've put some things on top of it. It's sort of pretty generic slides that we used when I go around and sort of talk about us, right? It has things to do with our company. It has a bit into hearing aids, but I really want to be guided by what you're interested in, okay? So I've brought actual hearing aids, right? So I've got here two types of our hearing aids, and we can go pretty deeply into pretty much everything you want, right? So when I joined the company, I was developing the software for it, for fitting it. Later on, I mean, well, and up until now recently, I was very involved in the hardware, right? So we can talk about why we picked certain chips, and we can talk about power consumption, battery technology, the microphones we're using, the speakers we're using, I mean, the shapes. We can talk about whatever you want, right? So just if I'm dwelling too much, stop me and just tell me, let's swap to something else, all right? Until when do we have to go?
Well, there doesn't seem to be very much potential contribution from the when you want to break.
All right. So, all right. In the morning, right? Introduction, right? So I think that's probably what Peter covered, right? I mean, hearing loss is a problem, and that's pretty much what this is saying, right? This is a bit about how the ear works, and essentially you have the sound coming from the ear, which is here. It sort of comes here, vibrates the eardrum, and then you have these three smallest bones in your body that vibrate the cochlea, right? And inside the cochlea you have these small hair cells, and each one of them is connected to a nerve that goes to your brain, essentially, right? So that's how you get sound. So they actually found that each one of those hairs vibrates at a certain, or it's excited by a certain frequency, right? So there is a bit of liquid inside your eardrum, and then your ear, I mean, those hair cells essentially each is excited by a certain frequency, and that's how your cochlea splits sounds, which is lots of frequencies, into individual frequencies, and sort of does some sort of a Fourier analysis on the sound, right? And then each frequency is connected to its own nerve, right? When at the age of 10, I think roughly, we are at the peak of our hearing, right? And so it's bad news from that point on, right? I mean, essentially over time, even in normal people, let's call them, these hairs deteriorate, right? And so normally as we get older, the higher frequencies tend to sort of deteriorate first, which is part of the reason why as you get older, you feel like females talk, you can't understand them, right? And a lot of people will say, I can't understand the girls today talk very softly or so on. And it's more, on average, it's more to do with the fact that female voice is higher frequency, right? Some people are born without without some hair cells or damaged hair cells or no connection to neurons, and so those people are very deaf, and essentially hearing aids won't really help them, right? Because there is no connection past these hair cells, and so sometimes you can treat it with cochlea, right? So putting electrode inside and sort of stimulating those nerves, but if there isn't a connection at all, then you don't have any option really. Hearing aids. So what we do is for the people that do have hair cells that are damaged, so we do sort of mild to moderate hearing loss, and essentially that's where hearing aids really are used in the public, right? Where most people have some sort of degree of hearing loss, and so we essentially, in the most basic term, we just amplify it so they can hear sound better.
Can you go back a step?
Of course.
Are those hair cells resonant or white band?
What do you mean by that?
Each one, they're not kind of frequency sensitive.
They are frequency sensitive. So each cell, each hair cell. I mean, well, I think I'm not too sure, right? I mean, I'm an engineer, but I know each hair cell is excited by a certain frequency, right? So not by a range of frequency.
So it's an FFT.
Exactly. Yeah. Your ear does an FFT. Yeah, your eardrum, correct. Traditional model, and again, Peter probably spoke about it, but traditionally you would go to an audiologist. The audiologist will put you in a soundproof room, will do an audiogram, fit you, and then you'll go home, and then you'll come back, and she'll adjust it, and you'll go home, and you can do that many times, right? What we've done is done a slightly simpler model where we took everything from making hearing aids to our model to having our own audiology clinic, and we sort of have this thing where you can do an online test, and the test's result is saved into our database. You can, from your home, get the hearing aids pre-programmed to you, and then you can use your phone, your computer, an e-case. You can call us and fit your own hearing aids. So self-adjust them completely yourself or not at all, right? So it's totally a spectrum, right? You can also have our clinics. And the beautiful thing is that we are very unique in having this database, and so every time you save a fitting, we get the results in the database, provided you accept it, of course, right? And so we have a massive database of over 7 years of fittings and how a fitting changes for a particular person or how a fitting changes in general, right? I mean, it's sort of very, very interesting data. Costs, I'll skip that. Why we want to make a difference. And I think you've met Peter, and I mean, you can really see from Peter and both Peter and Elaine, I mean, they're such beautiful, genuine people. They really started this business to make a difference, right? And I think it's really beautiful the way they're selling hearing aids for the price they should be sold rather than the price that they can sell, right? I mean, so hearing companies are making insane revenues. And so, yeah. Any questions? Yeah. So the part 2 is more about making a hearing aid, right? And it sort of covers design and hardware and firmware and software and manufacturing and iterations. I mean, again, I can talk about lots of things. So I'll just start, but please interrupt me more, right? And tell me if I'm going off track. So design, right? So design is super important. So if you have experience with hearing aids, and you probably do, hearing aids kind of look the same everywhere you go, okay? And that's, we felt, is a real problem because it's a barrier, right? They look ugly, right? And so if you look, these are all hearing aids by different companies, but they all pretty much look the same. This hearing aid and this hearing aid, again, they pretty much look the same, but one is from 1996 and the other is from 2017. Whereas fonts, right, if you compare the two periods, they've changed drastically, right? And so I'm not saying the technology hasn't changed inside those hearing aids, but they've physically stayed the same. And that brings with it lots of problems. So the main problems is changing batteries. And again, I can sort of go off on a tangent, but it's not very technical. So let's just keep drilling in. And so in the design, what we did with this facet product, which is our first hearing aid that we've created ourselves, is essentially take a hearing aid and break it in two, okay? And what this really does is create something pretty beautiful, because now all of a sudden you achieve few things. So number one, by having it modular, you can change batteries pretty simply, right? So if you have the battery here and I have the actual product here. So if you want to change a battery, all you do is you take one module and you take the hearing aid and you just sort of clip them together, right? They just have magnets. So they literally just click together, okay? And that sort of simplifies the changing of the batteries tremendously, right? So when we first trialed this product and we had some people come in to trial it, and one of the people, it was quite amazing. I mean, she couldn't really sign the consent form to say, right, she's not going to say anything about the new product until we release it. But for the first time in her life, she could put these magnets together and on her ear. So it sort of completely freed her, right? So it's a very simple solution that really changed their lives, right, for her. But also you do other things. So hearing aids are super expensive. I don't know if you know, I mean, you can spend up to $12,000, right, on a pair of hearing aids. And the actual chips inside of them change very, very rarely, right? I mean, to develop one of those chips, so the chip that we use, we didn't develop it, right? There are few companies around the world that develop those chips, a bit like Intel, right? And these chips, I mean, so the chip we're using, I don't know, I think the cost was something like $21 million to develop, and it took 5 years, right? But hearing aids are being released every year, right? Even though they have the same chip, okay? And so really in terms of the brains and the smarts in the hearing aid, not much is changing, right? Firmware is changing, algorithms are changing. But I mean, the things that are failing are things like how it physically, right? So the batteries, if it's a rechargeable battery, right? So you might have to send your hearing aids for repairing and all sorts of stuff. But by having this modular structure, we can keep the brains the same, right? And we can only change these modules, right? And so if this year you bought a hearing aid that didn't have Bluetooth, right? But in 2 years you want to add Bluetooth to your hearing aid, all you need to do is just buy a module that has the extra hardware for the Bluetooth in it, okay? And so that allows you to, with minimal cost, upgrade your hearing aid, right, to whatever sort of technology you want. And there are a few other things. I mean, repair obviously is easier, right, because you can just throw out these modules and get other ones. And so the cost of maintaining and upgrading your hearing aid is improving. So this is the hearing aid, right, and you can sort of see how you can pretty easily separate it. There is a video. Should I play it? Yes? Okay. Doesn't look like there is sound.
Rescue's on the way.
It's okay. We can probably. I can try and talk through it. Yeah. Doesn't want to play. There we go. Yeah. Okay. See that. All right. So obviously it's a marketing video, right? So and we're very biased, right? I mean, I work for the company and I've never worked for any other hearing aid company, but I do believe in what we do. Essentially, what you could see is a person doing this SPT, right, a speech perception test, and that's something that's very unique to us. He's done it online, so you can do it. Everyone can do it at home. It's free, and essentially from that we can tell. We can get a very good idea about your hearing, right, which is quite beautiful. And so we use that to program the hearing aid and send it over. Hardware, okay, so choice of components, and again, here it's something where the slide is pretty basic, but I can go a bit into details if you have any questions. So the hearing aid is pretty simple, really. I mean, it has that's a chip that I was talking about, right? It's called, this chip is an Azaro 750, developed by Onsemi. You have a battery, you have a push button to select programs, you can have one microphone or more, we use two, and you have a speaker. So inside, actually, it's not a very complicated device, and that's what I was saying before. By having a modular design, right, you can keep all of that the same in the brain of the hearing aid, and you can add in other things, right? So we're thinking about Bluetooth functionality, we're thinking about something called NFMI, which is near field magnetic induction, so that allows both hearing aids to talk to one another in a very power efficient way. We're thinking about maybe a fall detection. So if you fall, then it can sort of raise an alarm, pair to your phone, or do things like that. Any questions about any of the components or something you want me to talk about?
So they're suggesting that everybody uses that chip?
No, not everyone is using this same chip, but Onsemi is one of the biggest chip manufacturers for hearing aids. So they bought up all the other, I think it's called independent, right? So essentially the world is divided into 5 massive hearing aid companies, right? And they, I think 3 of them developed their own chips, okay?
So it's Onsemi, is that?
Onsemi is the one that we're using. And they sell, I think other companies like Panasonic are using Onsemi, but there are lots of companies around the world that are using Onsemi. And then there are these 3 other big hearing aid companies that develop their own chips.
What sort of price is that chip?
It's quite expensive, right? I don't know if I can share that, but it's
If I go to Onsemi, will I find it?
No, you won't. Okay. And actually it was quite interesting because it's such a specialized chip, and making a hearing aid, it's not simple. They actually wouldn't really talk to anyone, right? So you need to really get their attention before they'll even agree to sell you a chip. And so we managed to do that only because Peter and Elaine are quite well known in that hearing aid space and have known the people that work in Onsemi for a long time. And so it was really through that direct connection that we, a tiny company out of Australia, could get access to this chip because they were convinced that our engineers know how to develop to this chip. Because the most expensive thing for them is to have people trying to support hearing aid companies that are trying to develop software and algorithm and firmware to these chips and are making mistakes, right? And so we had the code pretty much ready to go when we were talking to them, okay? But they're very expensive chips as far as chips go, right? Of course, these other hearing aid companies make their own. I mean, the manufacture them of the chips, I'm sure, is pretty cheap. But for them to sell it to us and recoup, right, that 20 or whatever $1 million that they use for development is quite a lot. But feel free to go and search online, and maybe there'll be an answer. Okay. Any other questions?
It appears that the speaker is acoustically coupled in the main body of the thing, although you down on the bottom right of the diagram that you've got what looks to be an electrical speaker that would be.
Yeah.
I'm not quite sure what's happening there.
Sure. Totally. Good point. So this is what's, I mean, so in the shaded diagram of the hearing aid, right, which is just what I could find online, the speaker is embedded in, right? And so there are many types of hearing aids, right? Some put it outside, and I mean, our facet puts it outside, okay? But you can get hearing aids where they put it in. So there are advantages and disadvantages to both, right? When you put a speaker in so close to everything else, speaker is pretty noisy, okay? Also, it means that the sound now needs to travel from here all the way through a tube to your ear, okay? And so you need to calibrate for that difference, right? Because the sound, depending on how long that tube is, it needs to bounce and stuff, right? So we do sell actually hearing aids with a speaker in. The benefit of having a speaker in the hearing aid is that you can make it bigger, right? Because as soon as you put it at the end of the tube, and I don't know if you can see it, but I can pass it around. As soon as this is in your ear, you can't make it too big or it won't fit in the ear. So most of the most powerful hearing aids do have the speaker inside, right? Because it allows you to just put a physically bigger speaker and then just have a hollow tube traveling to your ear. Okay? Anything else?
Telephone. People
Yes.
have trouble hearing on telephones.
That's right, yes. And so, I mean, there are few solutions there, right? So, in Australia, all hearing aids need to have something called a telecoil, and all it is just a coil that's wrapped around, right? And so, what it picks up electromagnetic signal and converts it into sound, right? And so, some people to hear through a phone will have a sort of a neck loop, right, which is another coil around your neck, and that connects to a phone, right, just with an audio jack, or there are many ways to do it. And then that sort of provides a very clear signal, right, because there is no noise from anything that's happening around you, right? It's just this direct EM signal going to an EM, right, and then through sound. Other hearing aids have Bluetooth, right, and so you can again connect directly between your phone and Bluetooth, just like you do with wireless headphones, and stream that way. Or people, essentially what they do is they put the phone very close to the microphones, and then that amplifies the sound. Does that answer the question, I guess?
With a phone, she can't hear very well.
Okay.
So she says it's really distorted.
Okay. Sure. So, I mean, there can be many reasons for that, right? I mean, it's hard for me to know why, because I don't know what hearing aid she has, what sort of hearing loss she has, and what fitting she has, and what, right? So, I think but there are many solutions again, right? So, is she in Australia? So she will have Telecoil in her hearing aid, right? Because to sell it in Australia, you will need to do that, right? So you can look into Telecoil solutions, right? And that's one simple thing. But otherwise, you can try and change the fittings. Maybe when you put a phone close to it, it clips or something. I don't know. But theoretically, can she hear well in general? If someone talks to her?
Yes.
Okay, well, I mean, what about putting the phone on speaker, right? Yeah. So there isn't really a magical solution, I think, but hopefully that covers it.
Just a quick question.
Sure.
What percentage of the power is used by your signal processing and microphone and speakers? What takes the bulk of the power?
Yeah, interesting question. So our hearing aids in general consume roughly 1 milliamp. I think the microphones are about 0.1 milliamp each, and I would say the speaker maybe 0.3 milliamps, right? And so the other stuff, right, is the microcontroller. But I mean, it's hard to calculate, right? Because it's also power conversion. So you have regulators from the battery to the powering up the circuit. Yeah, but that sort of gives you a rough idea. And also, but again, so that's without a power speaker, right? So with these really powerful speakers, it will increase. And also depending on your fitting, right? So if you just adjust the hearing aid to amplify the sound more, yes, it will increase the power consumption of that speaker.
A couple of questions arise for me, actually. I'm interested in the fact you're putting the speaker in the ear at the end of a wire.
Mm-hmm.
The hearing aids that I haven't got on today are the tube type.
Mm-hmm.
Does doing that affect the susceptibility to feedback? I test that my hearing aids are working just by doing that, and I get a squeal.
Uh-huh.
And when Bern mentioned about the telephone, that's part of the problem of bringing a phone up to your ear as well. It will tend to send the thing into oscillation.
Absolutely, yeah.
Do you think that reduces the probability?
Of course.
Yeah.
Right, and so for a very simple reason, right? Your speaker now is much further
Separated,
away
yeah,
from
yeah,
the microphones, and I mean, depending on your hearing loss, what you do is, as your hearing loss increases, you can start putting sort of ear tips, they're called, right? It's like silicone earbuds that, again, you have on headphones that, depending, again, on how bad your hearing loss is, you put more and more occluding ones that separate. But if you completely separate the output of the hearing aid from the microphones, you will never get that squealing, right?
Yeah.
And so you can go all the way from wearing them just like that, and that the benefit of it is that sound comes in from the hearing aid, but also from the natural environment, right? And everyone picks up sounds from natural environment, so it feels more comfortable and nice, all the way to having an ear mold, right, which really blocks everything, and all you can hear is the output of the hearing aid, right? And again, the feedback canceller works. I mean, yeah, if the feedback canceller works well, it should remove.
Well, it will. Yeah, it'll sort of squeal and then it'll wind it back.
Exactly right.
Yeah,
yes.
absolutely. Now that sort of reminded me of something else. I've got a friend in Florida who's really seriously deaf, and I'll be sitting with him and I'm talking to him, and I'll say, "Fred, you've got feedback there. I can hear it, and he can't."
Sure.
And now something else. No, the DSP there is running on about 500 microamps from what you're saying. I think I just sort of did the sums in my head. Got about a milliamp, and you've got a couple of hundred microamps.
That's right.
for the
Yeah, that's right.
microphone,
Roughly.
and a bit going into the power amplifier and what have you. So about half a milliamp. What sort of clock rate's that running at, and what voltage is it running at? Because that, to me, is the kind of this amount of number crunching that must be taking place.
Yeah. So the voltage these chips, I think it can run on 2 voltages, but I think we're stepping at to 3.3
3.3 at 1.8.
Yeah, 3.3. That's right.
Yeah.
Yep. Yes. Now, but I think it can run at the far higher voltages, right? And so again, these chips are pretty versatile because the chip manufacturer makes them, and they don't know what battery you're going to connect to it.
Yeah.
Right.
But you've got just the one battery in yours.
Well, so no, really. I mean, so that's the whole point of the modularity, right? We have one battery, right, and that's the rechargeable. But you can also the idea is to develop a module that allows you to use those disposable batteries, and they're at a different voltage, right? And so, we've built a system so you can work with few types.
Yeah, you have some power conversion in there somewhere.
Sorry?
You've got some power conversion in there as well.
Well, essentially,
regulator of some sort,
it detects.
Yeah.
It's a pretty smart chip, and it detects what sort of battery chemistry it does. So it's a separate chip to the DSP, but the chip that regulates also detects what chemistry the battery is.
So is that chip actually a monolithic chip, or is it a couple of chips in a package?
So yeah, good point. So the chip we're using is a couple of chips in one package.
Yeah,
That's right.
yeah.
It's a Nordic chip and on semi chip, right?
Not what, radio, RF?
Correct.
Right.
Yeah.
Okay. And you have two. How are you using the 2 microphones?
Okay. So essentially.
That's a Dorothy Dixer, by the way.
But it's a good point, right? So microphones, essentially, by using 2 microphones, right, it allows you to do a polar map, right? And so essentially now your hearing aid doesn't just get sound and amplifies it. It can decide which direction it wants to get the sound from, okay? And so by having 2 microphones, and we try to space them pretty far apart, essentially, if you think about my hand being one microphone and this microphone being the other, if someone talks from the front, the sound will arrive to this microphone first, and then a few milliseconds after to the back microphone. Whereas if it's directly from the side, it will arrive at the same time, right? So in this way, by mixing those 2 microphones and setting them a pretty good distance apart, you can start building a polar map. And so what you were saying about that restaurant, if the hearing aid does its job well, it won't give you any sound from the back because you don't want it, right?
Yeah. Actually, when I mentioned that problem to Peter, he said, well, go back to the shop and get them to turn on the directionality,
Exactly right.
assuming that it's in my hearing aid. I don't know. I've got to say, I think I was flim-flammed over that hearing aid, buying those hearing aids. I don't think the people there really knew what they were doing other than ringing up the cash register. I do feel let down. I don't know if anyone else here has bought hearing aids, but I did feel somewhat let down by that whole thing. In hindsight, of course, because you don't part with $6,000 or $7,000 thinking you're being stupid, but in hindsight, it's kind of wonder.
That's right. Yeah, and it's tough, right? Yeah. I mean, but yeah, it's a problem many people face.
Yeah.
So I'm just trying to see here if I can actually show this polar map.
Beg your pardon?
What kind of pattern did you get from those microphones?
Pattern? Oh, I don't know. I'm seeing that placement there is new to me. I would have thought there was somehow front and back, but yeah. Bill's the only one checked out to push the buttons on that touch screen.
All right, so I've got a hearing aid connected here, and yep. You see, and you can see the polar pattern changing.
Oh wow!
In real time, right? So that's essentially the polar pattern in this hearing aid, right? And you can see that it's trying to adapt to the different environment, right? And obviously, right now I'm holding it pretty flimsy, right? And the sound is coming from in different direction, but you can see the hearing aid changing the polar pattern as it's trying to adapt, right? And decide where it wants to listen to. And so this is done all, again, in real time, and it changes, it's sort of adaptive, right? So, but again, we can choose, right, how it adapts, right? So that's all algorithms, right? So I actually just grabbed this hearing aid off my desk, so I'm not even sure what settings it has, but we can decide to keep it at a single fixed polar pattern. We can decide, I mean, you can program one program that will always listen just to the front, and you'll be interested to use that program if you're in a cinema, right? And so even if someone is talking behind you, right, or if there is a bit of sound behind you, you might not want to listen to it, right? So you can tell the hearing aid, don't worry about doing the hard guesstimates of where you want sound to come from and what I want to listen. You can tell him, I'm in this situation, only want to listen and to sound in the front. Okay, but yeah, this is the polar pattern, right? And so it's pretty cool, and you can see it again just changing as the sound comes from different places.
This is an on-semi program, is it?
No, this is a program that was built by the company Peter first worked in. Again, it was founded in Melbourne. It was called Dynamic Hearing, and then it was sold to Wolfson, and then it was sold to a company called Cirrus Logic. So these companies get sort of acquired, but I believe that Dynamic Hearing program, okay, so that company that Peter and Elaine founded, we're still using the same sound processing. Well, it's not true. We've developed on top of it, right? But we're using the same principles that Peter first developed for Cochlear, right? And Cochlear, again, is still using the same sound processing idea, but again, I'm sure they've developed much more on top of it. And so this is the software that, essentially, it's called the manufacturer's toolkit. It allows you to go into the hearing aid and play around with lots of parameters, right? So this is a wind noise reduction algorithm, but so wind is not detected, but let me just blow on the microphones. Right, so it's just a demonstration on how it detects wind, and then it knows what to do about it, right? And we can do a lot of stuff, right? So this is, and again, I sort of wanted to talk about this a bit later on, right? But this is showing how this is a frequency scale, right? So all the way from 0 hertz all the way to 8 kilohertz. And then you have the output of the hearing aid, right, in dB, all the way from 0 to 110. And so this graph shows in orange the actual output, again, in real time of the hearing aid. And the curves, I can talk about them a bit more, but the other curves are sort of the feeding of the hearing aid. Okay, so let's swap back and then keep some of the excitement for later. But again, feel free to interrupt and tell me if you want to talk about something else. Okay? So there we go. All right. So the technology, right? So it's a Bionic Ear Technology, right? It's we were trying to explain one of our biggest problems is that when you sell a hearing aid more cheaply, it's hard to explain to people out there why it's not cheap because it's crap, and it's because it's cheap because we think we can sell it more cheaply, right? And so we had to work really well on our messaging, right, and trying to explain to people, right, that the technology behind this product is really world class, and we are still selling it for half or a third of the price. So is this? Do you want me to explain what this diagram really is? Yeah. Okay. Let's go into it. So essentially, what the hearing aid does is, okay, let's start with the fitting, right? So you have the fitting, and so using that fitting, you personalize what the person hearing is like, right? And so this is again just a random example, but let's say we have few lines here. Let's start with this one because it's the easiest. It's called the MOL, which is the maximum output limit. And all it does, it puts an umbrella on the sound because you don't want to damage a person's hearing. And there is a certain point where the sound is just too loud, right? So all it is, it's saying from this line up, the hearing aid will never, no matter what, output any sound louder than that, right? And so that keeps the hearing aid not sounding too loud and really hurting your ear. I mean, not physically hurting it, but I mean just it's cringing sound, right? You don't want to hear that. Then you have a line called the comfort targets, and that's a line where essentially you're determining across the frequencies where is it comfortable for the user to hear, right? So in a perfect world, right, you'll hear things pretty comfortably here, but as you get hearing loss, it might change across frequencies, and it might get sort of higher, right? So you need a higher output to hear it. So in a perfect world, and if we had infinite processing power, we would just want to output sound here, in theory, right? Because that's what's comfortable for you, okay? Then you have the name escaped me, sorry, the audibility targets, right? And that's more around how you hear soft sounds, okay? Then this is where it gets a bit more interesting, right? So you have, what we do is and the reason why we chose these chips and why these chips are so specialized is because they do Fourier transforms super fast, right? And in a super power efficient way, okay? And so these are all the bins, right? So you get the Fourier transform, you split it up, and then you get bins across the frequencies. And then, okay, our fitting, our sound processing is very different from everyone else. And I think Peter touched on it, right? But one of the reasons is that other fitting sound processing schemes use anywhere between maybe 8 to 12 bins, right? So each one of these things is a bin, right, and it covers a certain frequency. And in this hearing aid, you have 128 in this chip in particular, right? And so it's a bit like resolution, right? But I'm tricking you a bit, right? Because the other hearing aids can also sound great. It's just that we're using a different ways of processing sound. But we feel that this way is more natural, right? So again, in a perfect world, if you cut this up to 2,000 bins, right, you'll get a better sounding hearing aid, right? Because you can separate more noise from signal. So what you're seeing here in blue are the gains, and maybe we'll swap again to the live view. Okay, and here it's going to be a bit more. It's less nice, right? Because you see, I mean, the fitting is pretty random. All the gains are the same value, right? And that's never going to happen in real life because everyone's hearing is slightly different, right? So the gain will be different across different frequencies. But you can still see that there is a blue part, and that blue part is called the maximum gain. So again, similar to this shaded region, at a particular frequency, you don't want the hearing aid to amplify above that blue line, right? So it stops the gain that the hearing aid will apply at a certain frequency. And the orange stuff is, again, the live gain that the hearing aid has at a particular frequency. And you can see that it sort of, again, changes dynamically. And actually, in the hearing aid, these orange curves change way faster, obviously, right? It's just that this software is just taking samples at a certain point, right? So what we can do is, if there is a lot of noise next to the microphones, so let's just, I'll try and just tap it or something, you can see how the gain goes down because the microphone's now receiving a lot of noise and the hearing aid is saying, this is too loud, I'm going to try and bring it down, right? So by bagging the hearing aid on the desk wasn't a great idea. But let's just try and connect again. So I probably just disconnected the wire. Right, so we'll give this another go, but essentially you could see that as I was banging the microphones, right, the gain got lower because essentially you don't want to amplify the noise, right? And so it was a nice demonstration to see how the hearing aid performs in real life. So while we connected and we are here, you can see again that there are huge amount of configurations file, right? This allows you to burn new firmware. There is massive calibration tables. And so when we manufacture a hearing aid, every single hearing aid we manufacture, we calibrate it. And so what it means is you put it in a sort of soundproof box and you play some tones and you make sure that even though it's the same microphones and the same speaker, right, and the same circuit, I mean, the actual variation in those components needs to be calibrated out, right? And so these are all the offsets that we apply. Input calibration, you got voice prompts, right? So you can record voice prompts for the different programs. Prediction, that has to do with how, so again, you can see, right? On that graph, I was talking about the comfort targets, I was talking about the audibility, and I was talking about the MOLs and the gains, right? So these are the maximum gains, those blue squares. That's the maximum output, right? That top shaded region, that's audibility targets, and that's where it's comfortable. But you have other things too, right? And so there are many, many things that are playing around, and there are many algorithms on top of that very basic, right? There is sound coming in, those 4 curves, right? But this program essentially tries to help you look at the different areas. You've got MDA, that's a sort of area of the memory where we keep lots of information. 1 second. So this essentially, by our software reading this table, it can tell what model hearing aid it is, right, who it belongs to, what's its serial number, all sorts of things like that. Then you have the programs, right? So this particular hearing aid can have up to 4 programs. And again, you have each program you can set up its own parameters. You can set inputs, right? So by me pressing this telecoil, I'm essentially telling him that I only want to, when the user is in this program, the input will only arrive from the telecoil, right? So the microphones are completely disconnected. Do you want to keep talking about this, or should we? Sure.
The different programs, I gather, are selected by the button on the hearing aid. How would the user know what program he was in? Unless you press it like 1, 2, 3, 4 times for 4 different settings, or does it give a different tone or something to indicate what mode you're in, or what happens? Yeah,
it literally has a voice prompt that says everyday music, wind noise, right? It's sort of, or you can have a custom program, right? Okay. It will say custom.
Thank you.
Okay. All right, so let's go back to the slides, but we can keep toggling if we're interested. So we spoke a bit about this. that this is about ADRO, right? So I think Peter again spoke a lot about ADRO, so I might just skim over it, but this is talking about ADRO as opposed to other amplification schemes, and how studies show that ADRO was significantly better. It had a I think there is a question.
I should point out to you that not necessarily
Everyone
these
was
people
here.
were there. In fact, who was there at Peter Blamey's thing? So about half the people. Yeah. So.
Okay.
Yeah.
Sure.
Yeah,
I'll go over it quickly, I guess. But if you have questions, and then we can try and go a bit deeper in. ADRO, essentially, what this slide is sort of saying is that if you have at the bottom, right, two very soft sound, and at the top very loud sound, right, that's your dynamic range, right, and sort of trying to visualize your hearing, right, and oops. So essentially, okay. So the dynamic range, right, changes depending on that didn't work, but it changes depending on what sort of right. So some people might hear only the top part, right? So the very loud, yes, because they have some hearing loss. So it's trying to visualize the two sound processing schemes. That's compression. Compression, what it does, right? It amplifies, right, the low intensity sound more than the high intensity sound, right? So everything falls in that range of the person, right? But you do get this less natural sound, right? Whereas ADRO is not giving you all the information, right? So it's cutting some stuff out, but people do think it's more natural, right? So this is again trying to show that, but let me just skip it. This is a video on ADRO.
The incoming sound is picked up by the microphone and split up into many narrow frequency bands. ADRO acts like an automatic graphic equalizer at each frequency. If sounds are too loud, it makes them softer. If sounds are too soft, it makes them louder. Otherwise, it leaves the natural qualities of the sound unchanged.
Okay, so a bit of repetition, right, between the live demo and here, but essentially it's just showing you, right, again in live what sort of the ADRO amplification does. Now we're sort of starting to talk a bit more about how ADRO is different in the fitting. And again, that's where things start to get very blended, right, because you have because we do end-to-end, we sell to customers where we do everything from the software to the fitting to the hearing aids, we do it all. So it all sort of starts blending together, right? So traditionally you would go and get an audiogram, and I think Graham showed me the audiogram of his wife at the start, right? Sure, and essentially that's what's done in a soundproof room, right? You will go into a soundproof room so you don't hear anything else, and this machine that's again very highly calibrated and sophisticated will play sounds and sort of increase the volume until the person can hear it. And what we are trying to do is do something slightly different, right? So let's start with that SPT, this is the result, and like I was saying, you can do it online. And the difference is that instead of listening to beeps and different frequencies, you're now listening to words, right? And so it tells you different things about your hearing, right? Because, I mean, well, we all talk in words, right? And so the analyzing words we feel is better, right? So more accurate. Right, and so this is a result, but you can see, right, how you picks vowels and sort of ranks all those things. And the other way is to do balanced loudness. And what you do there is when you actually connect the hearing aid in your ear, you play 5 tones, similar to the audiogram, and you adjust them. The difference is that now you're doing it with your ear and the speaker you're actually going to use and the hearing aid hardware you're going to use, and you're going to be playing those 5 sounds and adjust them based on your ear canal, right, as well. So the acoustic and everything is as it is in real life, right? And so traditionally people will do the test online, they'll get the hearing aids, and then when they get them, they'll connect them to software, and they can do it on an app or a PC and just adjust these sliders. And we can actually do that here if you want. We can sort of go through fitting a hearing aid. This is some lessons learned from research, right? That essentially it's essentially saying louder is not necessarily better, right? So there is a certain point where even though the loudness increases, right, you have the satisfaction reduce. Okay? And we're on to the software, right? So, is there a question somewhere, or should I keep going? Yeah?
No, keep going.
Oh, I think.
Well, I've got a few questions, but we'll just break up your talking a little
Sure,
bit.
sure.
Do you see, it seems to be a lot more socially accepted for people to have things in their ears now, especially with the latest generation coming through.
Yeah.
So I'm not sure smaller is better anymore coming through. But do you think the likes of what Apple's doing with their Apple Pods and that sort of thing is actually going to take over from the hearing aids? Are they going to come out and be able to do a similar sort of function by using more off-the-shelf technology?
Totally, right? Absolutely, they are going in that direction, and Bose has got a special permission in the U.S. to fit over-the-counter hearing aids, right? So, all right, stop me, but I mean, all those things are massive stories, right? So the whole world is of hearing aids and these consumer electronics is sort of colliding now a bit. And it's a very, very interesting time, right? So, and what Bose has done, okay, the difference between the US and Australia is that in the US, you have to have an audiogram and an audiologist, I believe, to fit a hearing aid, okay? And so what we're doing here is illegal in the US because Australia doesn't have that restriction, okay? In Australia, you don't need to have the audiogram to sell a hearing aid, okay? And so we have been trying to advocate that it's in the US, that, I mean, it's better, right? I mean, we can do that, right? We've been doing it for 7 years and we've gotten as good results, if not better, okay? So what Bose has done is they've done a study where they've shown that a similar thing, right? So they have their own way of processing sound and doing the fitting, right? Which is, I think, similar, right? They give a user some app. And what they've shown is that they can fit these devices and the user gets as much benefit, right, or better with those devices, right? So the FDA, for the first time, gave them a grant, essentially permission to use that technology and sell over-the-counter hearing aids. And that's sort of crushed the share prices of the big hearing aid companies, right, overnight by 10% or something, and then generated massive excitement. And now in the US, they're working over these over-the-counter hearing aids, which are hearing aids that you can sell just like we sell ours, right? You can just go to buy it from, like you buy headphones, okay? So is that going to be the future and our hearing aids going to be completely destroyed? Probably not, right? It's going to be probably somewhere in between. What we found is, well, I mean, I'm saying, right, you can do it with your phone, right? You see pretty picture of iPads and phones and computers. You can do it all at home. But when Peter and Elaine first launched the business, they found that some people really want this human interaction, right? So even though they could do it all, they really needed someone to come and just sit face to face and show them how it works, right? It goes a long way. And so we addressed that by doing two things. Well, first of all, the idea was, well, there are audiologists out there. Let's approach them and say, do you want to sell our hearing aids? They essentially said no, because we priced our hearing aids so cheaply on the website that there is no margin for them, okay? So financially it wasn't viable. So we started opening our own clinics, and we call them sort of super clinics, right? We have one in Melbourne, we have one in Sydney, one in Brisbane. Then we get people traveling from New Zealand to Melbourne because the flight was cheaper still, right? Buying the hearing aids and flying back to New Zealand, right? So no, an online model is probably not going to work altogether yet, right? But it is improving over time. I mean, when I remember 5 years ago, we spent as much time. Okay, sorry. The second part we're doing is this teleaudiology, right? So you can ring us anytime now, and we can connect to your hearing aids remotely and help you. Again, we're not sitting face to face, but we can take control over your hearing aid. We can change the settings and can ask you how it's feeling, right? And when we first launched this, we used to spend 30 minutes, an hour and a half just explaining to the person that they have Bluetooth on their computer, what is Bluetooth, how to turn on Bluetooth, right? Or even how to turn on the computer, right? We had IT people, right, showing people for hours, right, through screen shares, just turn on the computer, right? Oh, it's Windows, I don't know, 98, right? How do I update it? Can I connect, right? I mean, all this stuff, whereas now we hardly have these problems, right? So most people know what Bluetooth is, or if not, it's pretty simple to turn on the phone, right? But yeah, it's a great question, and so no one really knows the answer. People are spending tons of money and thoughts about how the two words will merge, and they probably will complement each other in a certain way.
And do you think the next generation, right, is going to have any better hearing than the previous generation? Because OH&S has come in, right? So hearing protection in industry is as best as it's ever been. So those people that's lost their hearing via workplace is one thing, but that seems to subside now with any luck with OH&S.
Yeah.
But with the younger generation having things in their ears all the time, is it actually, do you know if it's actually going to get worse with the next generation coming through?
I suspect it will get worse, but I don't know if I have enough data on it, but totally, right? And so this is something really interesting, right? So what was the things that I was doing, and I don't have it in the slides, through this product, is I've taken our company and made it ISO 13485, which means that we are a medical device manufacturer, right? And so these hearing aids are a class 2A medical device. And so you have to prove and you have to show in great detail how we're not going to damage the right? I mean, it's a medical device. You don't want to do any more harm, right? But at the same time, you can buy for $5 headphones, right? And they will amplify way more than our hearing aids can physically. And you don't need any permission, right? They don't have any ISO, anything, or right? And so you can just keep turning the volume up and damage your hearing. Yeah. Right. So I think it will get worse, right? Probably more people with, I guess, not as severe hearing loss, but still severe hearing loss. Versus now you have those people that, I mean, we get people that play in symphonies, right, and sit right in front of the trumpets, so they get one ear much worse than the other. Or dentists will have one ear, or people, right, that shoot. Anyways, right? So yeah, definitely you get that. But
one more while I got the microphone.
Sure.
Your product lifecycle management. What sort of software do you use from the upfront design side? Do you have a suite of products that goes through the actual design and the layout of the device all the way through the electronics side of it?
Okay, I'm not sure if I understood the question. I think there are a few things there. Can you say? Can you try and ask it again?
Certainly from the software side that you use within the development, even the physical shape of it and that sort of thing. What sort of 3D modeling packages and that sort of thing do you?
So we use SolidWorks, right?
SolidWorks, okay.
So I mean, in this project in particular, we used SolidWorks for the 3D design, and we've started with other modeling. So we engaged the designer to try and make the hearing aid more beautiful. And so it went through a few things, but it ended up as a SolidWorks model, right? And that's what we used to generate the drawings and send to the productions. But we also had Altium, right, generating the schematics and the PCB. And inside this hearing aid, I don't know if I have a picture, but it's a flexible PCB that sort of bends and curves around. And so we had to use Altium to export this 3D model, right, and bend it, and then put it in that SolidWorks shell, and obviously do iterations. And I think we have, 150 something 3D printed models. Anything else? All right. So I hear you, right? So that's the software that I started when I came in, right? The idea was these smartphones were popping by, and they wanted me to put the software that will fit the hearing aids into a smartphone, right? So that's the first thing I did. And essentially, it's what I was talking about, right? It allows the user in the palm of their hands to fit the hearing aids. And our audiologists in these clinics are using exactly the same software that you can download for free from the internet, right, and use with our hearing aids. And again, so I can talk a lot about the software. Before I go there, right, I can talk a lot about the software. I have it here, so we can connect to these hearing aids and fit them to someone, or we can change things in them, or whatever, right? But the slides here are more around the speech, and essentially you'll see this graph, and that's a screenshot out of the program, and you can see a similar thing to what we were seeing before live. You'll have the speech line. You've got the comfort target, right, and that's a speech peaks and comfort targets. Then you've got this bottom shaded region, which wasn't there before. And what this is that if you do give us your audiogram, we will show you on the screen in which region your ear can't hear, right? So if sound is here, you just can't hear it. So you want those comfort and speech to be above that. And then you've got the too loud region, right? So you get in the middle, this sort of bubble of where your sound is. And that's what this is talking about, right? So I can go more in details into any of those things if you want. Next is manufacturing, right? So we had this great concept about making a modular hearing aid, right? And I can now show it a bit better, right? So that's what we have here is a pod that it's a carry case, but it also your charger for your different modules. You've got here a few different modules, right? So if your battery runs out, you can just swap it for another one. And this is your hearing aid. You can hear it. I'll try and make it. Right, so it said the every day, which is how you can tell which program it is. And so that's the design, and we've worked on it, we've developed it, and decided where to manufacture it. We've decided to manufacture it in Melbourne. So it's a company in Glen Waverley, and we manufacture the devices there, right? So it allowed us. It's the first time we've done it. It's allowed us to really be in very close contact with them and understand and teach them and show them, right, how to progress through everything. Things that come into manufacturing, I mean, it's pretty obvious, right? Location, how manufacturable this is, right? So we had to do many iterations to make these things manufacturable, right? And it wasn't as simple as you'd think, right? So even though the device is made in Melbourne, the plastics are manufactured out of the US because there are very, very few manufacturers that can do this sort of injection molding, which is called micro-injection molding, right? So very, very fine tolerances. Then the plastics are sent to Germany to be painted because you want a very durable paint but very thin and very sophisticated. They have a very sophisticated way of deciding, essentially having a very sharp cutoff between where you have paint and where you don't have paint. So you don't want paint in this sort of where the hearing clicks together, right? So you get the very nice meeting on the two bits of plastic. And then the shells are coming to here, right? So we had to work with a lot of people, right? And it was a massive collaboration, right, to make this device manufacturable. Then you have the costs, obviously, right? So we still felt that it was the right thing to manufacture it in Melbourne, right? The costs are far higher. I think our cost of manufacturing hearing aids are probably an order of magnitude higher than other hearing aid companies, okay? Even though that is the case, we're still selling it, right, for half or a third of the price, depending on the model, okay? So this is our premium product. It costs $6,000, right, and it is made in Melbourne. We've sort of done everything for it. These other, for a pair, yeah, it's three or something like that for one. These other hearing aids I was showing you, these are the previous model we had, and we still sell them. And even though it sort of uses a similar chip, and the technology is pretty similar, right? Because you still use the same software that we've got and the same algorithms, but the actual hardware is from, I think it's from Asia, right? So we buy it from a company in the US. Yes, they manufacture it similarly to all the other hearing companies out of Asia, and then we just got the hardware and reprogrammed it, right? So we've moved from this to actually having control over the whole process and manufacturing our own devices. And then, yeah, quality and lots of things like that. So I think this is the end of my slides. And again, right, I mean, there are other points there that I can talk about, right? We have IP that we had to take care of. We had to talk to customers. We did focus groups. We did trials. I'm just connecting to one hearing aid, but we can equally as well connect to two, right?
Firmware, hardware,
So
regulatory stuff.
this is the
business,
program
right,
after
to
the
make
user
I mean,
already receives it, right?
Tell me what you want me to
the
talk
feeding
about,
is
or we
already
can
there and
end the night
everything is
here.
ready. But if I want to, I can go and set up the hearing aid. And so essentially before we ship out the hearing aid, we just put the client's name, we select which size speaker he has, and we can put in different audiograms. We can import the test from that online speech perception test. Or, I mean, because we have our database with all your fittings, right? And every time you adjust your fitting, wherever you are, again, if you agree to it, then the fitting is saved to us. Let's say you're in New Zealand or something, or Alaska, and you lose your hearing aid. Then we can program a hearing aid with your latest settings, right, and just ship it directly to you. Right? So that allows us to select whichever files we want. And okay, so we've got the main screen, and then when you connect to it, you just go to this balanced loudness, and that's what I was saying before. You have the hearing aid in your ear, and you'll play 5 tones. And let me try and play them. I don't know if the microphone is picking them up, but essentially it's 5 different tones in different frequencies. And then the user can play them as many times as he wants and just increase the volume or decrease it. It's pretty simple. Yeah? And so this way you can, again, sort of take, factor in when you do a speech perception test, right? We don't have any control over how loud the speakers are, okay? For example, right? So it's more focusing about the shape around the frequencies, and this allows us to fine-tune that a bit more, okay? Then you press save, and it will use that to recalculate your fitting, and you go to volume, where you can say whether overall this hearing aid is too loud or too soft, right? And you can sort of bring it up and down. So it's pretty simple, right? So you can just bring it up, it will adjust it, you can feel whether you like it or not, you can bring it down, you can save it. And then theoretically at this point, that's it, right? We don't want you to muck around with your hearing aids, right? Some people are very techy and they enjoy fiddling with them and they love it, right? I mean, we have some clients that go and watch birds, and so they'll adjust and have a bird program on their hearing aid, right, where certain frequencies that the bird chirp at, right, are picked more. I mean, so you can really play with it as much as you want, but for 99% of our users, this is the point where you stop. You go around and you just disconnect this cable and you just enjoy the hearing aids, right? If you do find that you want to sort of reduce sharp sounds, or you find that your own voice is sounding too loud or muffled a bit, you can adjust these things. And you can go to the fine-tuning page, which is really giving you control over everything, right? You can see that here I don't have the shaded region at the bottom, and that's just because I didn't input the audiogram, right? So it wouldn't know what it is. But I can go around and I can select the comfort line, I can select few frequencies, and I can go and just increase it, right? And again, it does it all in real time in your ear, and you can see, is it better, is it worse, right? You can select instead of it the speech curve, and again, you can bring it up or down, okay? And gives you really control over everything, pretty much. You're listening to real life, right? Exactly. Yes, and so the beautiful thing about the beautiful thing about having control is that, first of all, no one knows how you hear better than you, right? So instead of you trying to explain to an audiologist why it doesn't sound right, you can play with it as much as you want to make it sound right. But also, when you're at an audiologist's office, by definition, you're not in the environment where you're listening to most, right? So if you're in a coffee place and that's the place where you want to listen, you can take your phone and connect to your hearing aids in the coffee place and adjust it there, right? Or if you're in a workplace, you can adjust it, right? So it gives you freedom. You can go listen to birds and adjust it there, right?
Can you save multiple settings?
Yes, sure. So perfect, right? So this is the programs page, and you can again select up to 4 programs. We again encourage people to just have the everyday, because as you could see in those polar patterns, and as you could see with those gains, the hearing aid does a lot of the dynamic adjustments, right? So it really is very, very clever, right? So that you don't need to change programs all the time. But there are definitely people that want programs, and so if you want Telecoil, right, that's completely different input, so you can change into that, or you can add other programs, right? And it just sort of gives you a list of, you can have background noise, wind noise, music, telephone, theater, right? And it will sort of improve the settings there based on many, many other things, okay? And so, for example, theater will only focus forward, right? Because you don't want to hear people behind you. So you can add those settings in. Then you can go and you can do advanced settings, and here it lets you go right much more into it, right? It's very interesting, and again, people love playing with it. Some people love playing with it, and you can do a lot of things with it. But for normal user, they will tend to muck up their actual fitting, right? So they have a higher chance of destroying the way the hearing aid sounds, right? Yes, absolutely, right? And remember, every time you press save, those settings go. So we can, if you call us, we can go back in history, right? Or send you the first settings, or do whatever. Absolutely.
I was actually going to say that you have a big red restore defaults button, which you've just answered. So now, implicitly from what you've been saying, Yaniv, the hearing aid is able to talk back to the mothership, back to you, and I guess it's therefore it's got Bluetooth back to your smartphone, or you plug it in, or what?
Sure. So
presumably the smartphone is the intermediate step.
So you remember those modules? At the moment, it's connected through this device, right? So that's the Incus, and the Bluetooth is actually in this white device. And through that, it's connected to your phone or to your computer. So only when you're connected like that does it have Bluetooth, and
So
it's talking to the mothership, right?
So that comes with the kit.
Correct. Yeah. And
Right,
so
okay.
and we have a similar version for these older devices.
Yeah,
Okay.
yeah. Another question, if I may. You've mentioned the Telecoil,
Yes.
and that it's mandatory in Australia, because my hearing aids don't have the Telecoil, but I was offered a fairly expensive accessory to go with it to provide that sort of functionality.
Okay, so by the sounds of it, though, I mean, if the Telecoil is not in the hearing aid, no accessory will change that, right? So
Well,
what?
there's some sort of RF radio thing with it. You can buy a gadget to plug into the television,
Yes.
and to plug into the hearing aid, so I can get the television direct, which I haven't bothered with.
And so how would you plug it into the hearing aid, though? I feel like actually that gadget, all it is it will transmit the RF sound that will be picked up by the Telecoil in the hearing aid, and then.
Well, the two aids talk to each other. So there's obviously some, and you suggest it was a near-field magnetic coupling rather than RF coupling.
Sure.
And I'm
Yeah,
kind
there are
of
many
assuming
technologies
that
to
it
do
does
that.
that. You have this thing that goes around your neck and it's coupled in. I'd never really questioned it because I wasn't interested in paying another $300 for the television.
So that is normally what these things are is they will pair through Bluetooth or whatever to your phone or to the TV or whatever it is, and that loop around you is again it's just an electrical wire, right? That will essentially create one big telecoil around your head and transmit that EM field that will be picked up by a telecoil in your hearing aid.
So maybe EM rather than Bluetooth or something like that in that case. And you've got that little pod thing that provides the interconnectivity.
But we are working again on a module, right, that will allow you to have to just have a hearing aid looking like that and connected to Bluetooth.
Yeah.
Another question.
I have a microphone question, which if you can't answer it, maybe some of the people here can. At the start of your presentation, I mean, this is when tuning, when you're going to adjust the various frequencies, the microphone, you held it next to the microphone, didn't pick it up. I'm about 5 metres away, and I definitely heard 2, maybe 3 of those sounds sitting here. Yet you're a millimetre away, and it didn't pick it up.
Yeah, that's right.
What's wrong with this?
Well, no, it's actually very clever, right? It's probably doing some right? It probably has some feedback suppression, right? So these tones are very different type of sound from what, right? From what you want to hear in a microphone. So it's actually probably doing a very clever thing of suppressing that, picking it up and understanding this is not speech. I don't want to play that.
I'm interested to know how you're going to protect your intellectual property. What's to stop a little Chinese man extracting your software out of one of your hearing aids?
Sure. So extracting the software, that's probably the least of our worries. I mean, today you can have pretty clever encryption, right? That essentially means that even if someone gets it, it doesn't have anything to do with it, right? I mean, it can't do anything with it. Okay? So you can't just grab the firmware from the hearing aids, or you can't, even if you try and decompile our software, right, that we distribute for free, it first won't, I mean, again, we have protection, but you can probably try and decompile it and maybe you'll get something. But again, it's showing how to fit our own chip with our own firmware, with our own algorithms. I mean, it will just be garbage for everyone else. So that's the least of our worries. What we do have some patents is around the shape and modularity of this device, right? So it's the first and only modular hearing aid in the world. Okay, so that idea of just connecting it with magnets is really great, and that's one of the big reasons why at the start of the presentation I was saying about a month ago we sold the company, right? So one of the biggest, well, the biggest company in the world bought us, and that was because they felt we were doing something very unique, right? So it's both in the hearing aid space. They said, they literally are saying they cannot understand how with 5 engineers right here we can manufacture this hearing aid. We made it cheaper. I mean, the cost of the project was cheaper. We made it faster, so it takes them roughly 4 years to get a new hearing aid out when they've made hundreds of models already, and they have 500 engineers, right? So they found it very difficult to understand, but I'm not sure, right? I mean, yeah, I could tell them how we did it, right? But I don't know why they need 500 engineers and so on. I mean, I'm sure their engineers are doing something, right? So I'm not trying to be cocky, right? I'm sure that they're making amazing technology, right? And their engineers are very clever and doing great things. But yes, so we were bought, and so we did have some IP. I mean, this is very novel idea of charging it in this way, of replacing the magnets. We have IP around the sound processing, right? So that Adro has IP on it. What else? Anyways, there is IP all over the thing, right? But some other things they can copy, right? And probably there will be Chinese people that do copy it or from elsewhere, right? As you could see before, all the hearing aids in the world kind of look the same. Right? Anything else?
I've noticed with my hearing aids, Yaniv, that when I go to take them out at night, it changes the nature of the sound. And from that, I realized that my left ear and my right ear are different. I can't even tell you what the difference is, but there's definitely a very distinct difference to the whole sort of sense of the sound, the ambient sounds. How does your hearing test take that into account?
Oh, I think I understand. Great question, right? So yes, the hearing test that we do, the speech test, is you sit in front of a computer with 2 speakers, right? And you probably have 2 ears, right? And you're hearing the sound through both ears. So again, it has pros and cons. The pro is that this is how you hear sound in the real world, right? You don't hear first on the right and then on the left, right? But the downside is, you're right. If you have very, very big differences between your right and left hearing aid, this test tends to be much worse in terms of predicting it, right? And then when you come to playing those sounds that I was trying to do before here, that's where you do it right ear and then left ear separately, right? And so that's how we can account for those differences. I should point out, though, right, that we're not trying to completely make audiologists redundant, right? It's a medical profession, and it's a very important one, right? So sometimes hearing loss can be caused through a tumor in the ear, right? And so people should still go and see audiologists, and if we see those big differences, we'll refer people to ours or their audiologist, right? It's important to understand why do you have hearing loss, right? But in terms of fitting the hearing aid or to a selection of hearing and you want to choose which one, we think you should choose ours, right?
The other thing that this is sort of an observation, sort of calls more for comment than anything, I think. I think it was when I was on a plane recently, and the ambient noise on a plane is a lot of very low frequency.
Mm-hmm.
And I started to sort of cover my ears, and I was sort of pressing really hard with my hearing aids in. And that's when I realized that hearing aid is really only working at the high frequency end of the spectrum. That was my sort of observation. But you were showing curves there that go all the way from DC to daylight.
Mm-hmm.
And how much low frequency response is that actually in those things, given the microphones are so tiny and the loudspeakers are so tiny?
No, you can get whatever you want, right? So it's probably, again, just the fitting, right? So if you go to your audiologist, she can probably do what I'm doing now, which is selecting some more low frequency, right? So this is 125 hertz, and just push it up as much as you want, right? And I mean, I don't know if it will sound any good, but you can hear low frequencies.
So the hearing aid manages to get that low frequency response despite the fact the speaker is minuscule.
Yeah, that's right. So these speakers, they definitely work in those frequencies. On the contrary, actually, right after 6K, it's getting a bit less predictable, right? So if you look at the curve of the speaker, and I mean, again, you can sort of try and compensate for it with calibration, but as it gets to those higher frequencies, the speaker is sort of doing a bump and a pretty sharp drop around the 8K, right? And so the sound or outputting reliably the sound above around those 8K kilohertz is actually more difficult because of the physical speaker and microphone.
Yeah, but the conventional wisdom and telephony is 3.5K or something like that. So if you're getting up to the 4, 5, 6K,
that's right, exactly. There isn't much speech
you're
there.
good to go. Yeah.
Exactly right.
Yeah.
Good. Yeah, I think I do actually.
Do you have the frequency characteristic of the speaker?
Let me just find it and try and pull it up. All right, so I've pulled up the data sheet for our speaker. So you can see that it's made by a company called Sonyon, and they're again a massive company. They make our speakers and our microphones, and they probably make speaker and microphones for Bose and for a million other hearing aid companies and other things. So I think, yeah, you can see here the frequency response, right? And so, I mean, right, this is logarithmic, right? But as I was saying, right, around the 8 kilohertz sort of goes up and then down. And you can try and compensate for it with calibration, right? Because we are calibrating these hearing aids, and you can sort of try and put the calibration to sort of point up here and down there, but still, it's not very, very reliable because the variation between the speakers does change. Yeah. You can also, something I didn't say before is that this is, with the same hearing aid, you can actually connect a power speaker, right, which is more powerful. And so this is a data sheet for a power speaker, and you can see this disc, essentially what they do is the speaker is kind of floating with the wires. You will take an ear mold. These power speakers are only used with ear molds. So you'll take an ear mold and send it to a lab, and they'll put that ear mold in the shape of your ear canal with this disc, and then sort of cut off the disc where they need to, so you have a big speaker in your ear, right? And you can just plug it into the hearing aids right on the side, and that you'll see will have a higher output, right? So you can see the max and the typical, and so on. Okay.
While you're talking about that one, if somebody did need the ear mold, obviously that's not something that they can arrange themselves at home.
Yeah, that's right.
So would they come in to see you, or would they go to any other audiologist and get the mold made and then plug it into your machine? Or
yeah,
what would be
whatever
the
suits
procedure?
them, right?
Whatever,
So
okay.
yeah, absolutely, right. Most audiology clinics don't do their own mold, right? They would do the impression, but then they'll send it to a lab, right? So there are many options to get those ear molds.
Okay. Another question. I showed you the audiology chart that was passed around before the meeting. My wife, as you would have seen, has extreme hearing loss. In one ear, it's about 80 decibels down from 250 hertz. And on the other ear, it's about 110 decibels down for everything. And the audiologist that she's been to said, well, there's nothing we can do for the one that's 110 dB down. Just forget about it. Use the other ear. So they only sold her one hearing aid. But for somebody with such extreme hearing loss, would you suggest that they could do the testing themselves and with yours, or would it be better for them to come in and see your clinic?
Yeah, with that severe hearing loss, it's probably best to come to a clinic. Can I have a look at it again? Okay, yeah. So I'm just wondering, right? So if you look at it, right, it sort of goes from the top, and then around 750 hertz, it just stays at 115. And it's then just flat. It seems to indicate to me that maybe she doesn't hear below that either, right? Because hardly anyone's hearing is just constant flat, right? So she might not even have any hearing, right? It might even be lower than that 115. So our normal speakers amplify up to 115, right? It's really pushing it, but those high power speakers get higher, and you can get hearing aids out that amplify to 130 something, right, and more. So there are speakers that have pretty loud output, and so again, I'm not sure, because I mean, this is all the information that I have, but there'll be an option to either get maybe a higher output hearing aid, and I don't know, maybe if the audiologist didn't offer, it's either maybe they don't sell it, or maybe that's not going to be suitable. And then the next level after that, right, is, like I was saying, it's a cochlear implant, right? And so we have one of our staff that had a pretty severe hearing loss. He was wearing 2 hearing aids when he first joined the company, but he recently did get a cochlear implant in one of his ears, and that's made a massive difference to his life. But again, I mean, it's a surgery, right? They insert electrodes into your cochlea, right? It has a risk, and it actually normally does damage your hearing more in that ear. I mean, there are certain criteria. It's very expensive, but I think the government in Australia is actually very good at compensating. I'm not sure, right? There are a lot of things you can try and do. I mean, I would definitely try and investigate, right, and not just stop at the reason the hearing aid, right?
We better come and talk to you. Thank you.
Yeah, sure.